I'm not going to make you multiply out 6 binomials or anything like that, but just to review, you should be able to multiply these out. However, what I was finding was that people were forgetting how to do that. So I'm going to do it with you. When you do this, you're going to want to do 2 of them first. Don't try to do all 3, otherwise you're going to get confused, trust me. You're going to do 2 of them first, and then you're going to multiply by the 3rd after that. Alright, this is multiplication. I'm going to go kind of fast because this is algebra review. X times x is x squared. Then I have minus 2x, and then I'm going to have minus 5x. I'm not going to write those both down because I know they add up together to make minus 7x. Negative 5 times negative 2 is plus 10. Alright, now I'm going to do everything in here times everything in there. So the way I do that is I start here and then I just keep moving on. So here we go. X squared times x would be an x cubed. Then I do x squared times 3, which is 3x squared. Now I move on to the next thing. Negative 7x times x is minus 7x squared. Negative 7 times 3, negative 7x, is negative 21x. Then finally, 10 times x is plus 10x. 10 times 3 plus 30. The most unique math, doesn't she? It does have to make you smile, don't it? Alright. Can I simplify that at all? Yeah. Yes, I can. I can add some like terms. X cubed plus, minus 4x squared minus 11x plus 30. And I do promise you, I won't make you do at this point larger than degree 3 polynomial. Okay, now, I'm just going to show you. If I put this in, just if you wanted to check your answer, if I put this in, shouldn't its zeros be what I started with? Should. Let's see if it is. Yep. Alrighty, now, what about if I cannot find zeros algebraically? Then we should review how to do them on your graphing calculator. So I gave you a tricky one. So would you get your graphing calculators out? Not just one tricky, 3 trickies. And plug it in. And hopefully you'll notice what I mean by tricky. Ooh, before we start, how many zeros could it have? 4. Doesn't have to. Okay. So, I mean, what do you think? How many zeros? What's your thought? Okay. So now you see why a little tricky. All right, this is not tricky over here. Let's quick find that one because we know that's a 0, right? So the 0 over here is x is approximately negative 3.0, oops, if I rounded to 3 decimals, would be negative 3.100. Now here's what I'm going to do. Over here, I am going to adjust my window. If you want, you can do like the zoom in function. I am going to do like 0 to, I'm not sure about that. And then I'm going to do only negative 5 to 5, and I'm going to, if I can see it a little better. Still not great. It definitely comes up here. Do you see that a little bit? That it comes above the x-axis here. But I'm not sure if that bounces or goes below. So here, I am going to change my window again. I'm going to go only 0 to 2, and I'm going to go really close. So I am going to do negative 0.5 to 0.5, so I'm just looking right around the x-axis. Aha! So there are 4, aren't there? So let's find them. Who's got it on their screen? Okay. Connor, would you find this one, the first one for me? You already did. Okay. And then Alyssa, do you mind finding the middle one? Okay. And Emma, did you say you had it up? Do you mind finding this last one? Just so we don't have to waste. We know how to find zeros, so we're not all doing this 3 times over. Yeah. Connor, it's 0.5 exactly right. That's why. This was the only one that's exact, so I wrote an equals there. These are both approximate. What did you get, Alyssa? 1 point. Can you say it louder? I'm sorry. What comes after the 3? Because I have a neurotic thing with 3 decimals. Okay. 1.133? Okay. Emma? 1.367? Okay. Thank you. All right, good. So sometimes you're going to see some things today that you got to zoom in a little bit and investigate, and it's helpful to know how many zeros there could be. Uh-oh. Didn't I tell you about the volume of the box? Have we done this problem before? Please say yes. We did. We found the maximum volume of a box. Today, we're going to find when the box is 484. So here we go. We got this box. We cut out here. We fold. And this is like the bottom of the box. And the ones that are not shaded are like the flaps of the box. So that, like if you thought of Christmas time when you get a shirt for Christmas, that's what I think of. It's like a shirt box, shallow, and those sides fold up. So we find the volume of a box by doing length times width times height. Agreed? However, this piece down here, used to be 25, but I cut an X off each side. So what is the length of the box? 25 minus 2x, because I cut off X here and here. All right, and then this piece, this whole piece used to be 20, and now I'm cutting X off here and here, so now the width is 20 minus 2x. And this little flap becomes the height of my box. So what's the height of the box? X. You do not have to expand this. We are not going to do this algebraically. We are also going to graph, in this case, 484, and we are going to figure out what size squares, that would be x, we would have to cut out. So let's take a look. Okay, now actually there is going to be, we're going to find for our purposes there's two answers. There's actually more than two answers to finding their intersection. But what would happen after x is equal to 10? What would happen to the width of the box if I put something bigger than 10 in? It would become a negative dimension, right? And so when we're picking our window today, we're going to only make x go from 0 to 10. And I'm going to go from 0 to, I know it's 484, I'll just do 600 so I have some room to look. It's okay that I don't see the whole thing. I just need to see where it touches that line. So there's actually two solutions. Let's kind of do the same thing we did before, because I think you all know how to find intersections. So if you are in this half of the room, up to Victoria's row and down the middle, would you guys find the one to the left? And Nick's row to the edge, would you find the one to the right for me? All right, what did we get over here?
0.722.
This was 0.722?
Yes. 1.2.
Are you sure?
I got 1.2.
Okay. Check again. Did you maybe do something other than 484? No? Okay. How about over here? I think it was 6 point something if I remember correctly. 871? We're going to put some labels on that. Inches, inches. What that means is there's actually two different boxes. This one would be a shallower box because it only would have a depth of 1 inch. This would have a depth of 6 inches, so it would be a deeper, but the length and width would be closer together. Did you figure out?
Absolutely.
Oh, okay.